Okay, so hold on a second. I just want to make sure you guys are on the same track. So start with this question. Integration of secant to the fourth, 3x and tangent of 3x. And you guys all know how to do it. You guys all know how to do it? Okay, so we're gonna go to the next one. So integration of pi to the fourth, 0, and tangent to the fourth x dx. That's okay. Yeah. Yeah. You do not need to do DI. Just stay simple. Stay simple. Stay simple. Do not do DI. DI is only for LIATE combination or L by itself, I by itself. This is just trig by itself. Brandon, if you want me to turn your recommendation, you gotta send. I offer. I just don't have time to write one. You should have contacted me like way before the break. Don't contact people last second. They're not gonna do it for you last second. I was just like, oh, I might as well apply to one more school. Which school you already applied? No, we're not on DI. Like I say, the older thinking, you should not never should do DI first. DI is like the is combination of transcendental function. What I mean by transcendental functions, L, which is logarithm, I stand for inverse, e to the x sine of x is a combination of those, or it's just natural log of x by itself. That's integration by part, or arc sine of x. That's integration by part. That's the only times on integration by parts, not anything else. You guys done? Oh, that's weak. Anybody break through?
Certain words triggered like other lines for me. I just don't feel like
Misha, stop yapping. Get to work. Okay, you guys are done or no?
No.
Any ideas how to do it? Un momento.
Hold on, let me get my cookie, guys. Jenny, no big deal. Stupid. Yeah, I'm glad you
Nobody did? It's just a use up and trig identity. That's it. And that's it. It's not DI. It's not long division. It's not nothing crazy. Completed square. None of those. And simple math. Come on, intuitive approach. It's so intuitive. Everything comes so naturally.
We need to cancel.
Alright, seems like nobody got it. That'll be way too easy. That'll be way too easy. Okay, so obviously, hopefully, you guys start to understand that you can break the tangent to the 4 to tangent square of x times tangent square of x. Did you do that? Okay, so do you know that 1 plus tangent square of x is equal to what? Okay, so that means secant square of x minus 1 is like this, right? And what I'm going to do is I'm going to distribute. And I'm going to say minus 10 the square of x. Now, just look at this part. This is easy. This is just simple U substitution. What's U equal to? Okay, what is U equal to? Break up the two integral. This one should be easy because this one switched. This one can do it again. So it'd be secant square plus 1, right? Does that make sense? Now, what's this one? U is equal to what? It's right in front of you. You can have 4 options, right? What U is best be? No.
No. Oh yeah. Secant tangent.
It's minus 1, you're right. Okay, so what is U equal to? It's right in front of you. Good job. Why is U equal to 10 of x? Thank you. So that will be what? u squared du, right? Minus secant square of x plus 1. And now this one's u3 over 3, so it'll be 10 to the third x over 3 minus secant square of x plus 1. Now I'm going to plug in a boundary, pi over 4 to 0. 10 to the power of 4 is 1. Oh, integration secant is, oh yeah, I did do that. So what's the integration of tangent? Plus, yeah. So all I gotta do is plug in. So it's a 1/3 minus 1 plus pi over 4 minus 0, 0, 0. So that's it. So that's equal to negative 2/3 plus pi over 4. It's all something you know how to do. It's just like, okay, well. All right, let's give you some lighter one. Cosine to the third x over sine of x. Oh, square root of sine of x dx. Let's give you some light work. This is a light work. The other one's kind of hard, but this one's light work. Bennett, what are you doing? Cosine cube x over square root of x dx. You're doing the split.
But I'm getting Brian, stop pissing me off.
Stop scratching around.
You want to see me?
Insane if you. It's just.
So he's gonna kill me. He actually might murder me.
Oh,
Yeah.
what did you do?
So I'm a senior next tomorrow, and I didn't pick up lecture paper to fill out all this stuff. And then I was supposed to pick up a trophy and take a picture with you, Mr. Yang, but I didn't do that either.
Me? Why me?
You just choose a choose a teacher to take a photo.
Which trophy?
The DP trophy. I know. The friendship cup. I chose my calculus math teacher just because, just for funsies.
He wants the people on his team to think that he's smart.
Well, nobody's in calculus, so.
Calculus, what?
Yeah, but no other soccer players in calculus. Yeah, but nobody else. All right, so this is what I've done. I don't know. Maybe some people have different method, but I'm gonna switch it to cosine q. Every time you have odd power, I tended to work with that odd power because that one extra. Hopefully, that's the du part. So it'll be cosine square x times cosine of x over square root of sine of x. Right? So that's gonna be, well, that cosine square can be 1 minus sine square of x over square root of sine of x. And it seems like I have a du right here. Right? It seems like I have a du. So u must be sine of x, du equal to sine of cosine of x dx. So that's gonna be, this part is du, so this part is du. So therefore, it's going to be 1 minus u squared over u to the 1/2, and this is du. Which is that split up to be u to the negative 1/2 minus u to the 3/2 du. And this is u to the 1/2, 2, minus u to the 5/2, 2/5. So since u is equal to sine of x, so it's going to be like this. Is it good? What?
U is equal to what? You know what?
So what's 1 minus sine squared? The 1 minus u squared, 1 u to the 4. And but what's du though?
It's kind of long, but du is 1/2 sine to the negative 1/2 times cosine.
So much work. Okay, this one. Now this one is simple. Think even simpler. Think even simpler. You might not even need it. You might not even need a like trig identity.
Your brother.
This is easy, right? It should be easy. It's intuitive. We're gonna do one that's not intuitive mistake.
It's a Monday. I don't know what you expect from me. The AP exam's on Monday. That's different. That's different. Elliot, how do you already know exactly what day the AP exam is?
Yeah, that's kind of weird.
It's on Monday.
It is. Someone's a little sweaty.
Is it true?
It is on Monday. AP and BCT, they're the same day.
But it's on Monday.
Always, you're.
I don't think that far. I think tomorrow. That's it.
8:25 Friday.
Because of the way I view my life, I didn't have to worry about too far. I might go out the street. I can run over a truck. So why should you look that far? What did you say, Brendan?
He said you're getting hit by a truck a lot more than everyone else.
It's seeking, not seeking.
That makes sense.
Get it?
I've never do it.
I have a. That's why I have Tesla self-driving now. My wife doesn't even trust me to drive.
Because the Tesla.
Yeah, I've seen your car though. I don't blame her. You're not a blame.
You see my parking job?
You used to pawn and then do your lot, and I don't plan to exactly what the heck parts like that. And then one afternoon I watched you walk out like, what do you mean?
All right, so I was thinking something simpler if you can, right? Because if you do secant square of x minus 1, that doesn't really help you guys. So what can just do everything in sine and cosine. So that's gonna be 1 over cosine, and tangent square of x is what? Cosine square over sine of x. Okay, so that's gonna be integration of cosine cancel out, right? So it'll be cosine of x over sine square of x, and then yeah, that's just simple integral. U is equal to sine of x. Why? Because du is up there.
True.
So it'll be u to the -2 du, right? So it'll be u to the -1 over -1 plus c. So it'll be 1 over -1 sine of x plus c.
You don't even have to use them.
Huh?
You don't have to use them. The key is you can just make it cotangent cosecant, and you know that.
Oh yeah. Wait, hold on. Cosine over sine.
And you get cosecant going up. That becomes negative cosecant. And that's when you get
True. You are right.
He was not in
All right, so let's give you that. This to give you one I need to teach you. So now on trig integral, there was a special case. Is what if sine or cosine to the even power? Okay, so if you want to study, this is a question that I will definitely put on the test, because what if they are even power, right? So what's wrong with even power? Yeah, it had nothing to cancel, you're right. So this one, you want to go to thinking about power reducing formula.
Is that like where you do like cosine square, like 2x?
Okay, so what is power reducing formula? So let's start with the double angle identity.
They just started.
Cosine 2x. Most of you guys remember what sine of 2x. Cosine of 2x. Most of you guys, what is sine 2x, by the way? Yeah, there's 3 formula for that one. So I'm gonna show you that the easiest one to remember is this one, because it's almost like Pythagorean identity, but it's everything flipped. So it's start with cosine and with minus and the sine of x, and I think that's the easier one to remember. Now remember this one here is what? 1 minus what? Sine square of x minus sine square of x. So that's equal to 1 minus 2 sine square of x equal to cosine 2x. Now this one is just called double angle formula, but it's for cosine 2x, but the second version. There's another version, just switch the sine square of x. So you'll get cosine 2x is equal to 1 plus 2 cosine square of x. Or cosine, sorry. 2 cosine square of x. Okay, so now this one is called double angle identity. Now power reducing is nothing different. Power reducing is just you have a second power reduced to the first power. So what do you mean by second power reduced to first power? Imagine that you have this, right? And if I just evaluate sine square, that means I'm gonna move it to the other side. 2 sine square of x equal to 1 minus cosine 2x. And now divided by 2 on both sides. So that's equal to sine square of x equal to 1 minus cosine of 2x over 2. So now, to the even power, I can change to a first degree. So any second degree function, I can change to a second degree. So this one can also get down to cosine square of x is equal to 1 plus cosine 2x over 2. So a lot of you guys remember that that's the one other thing I asked you to remember. I said only for BC. So this is special situation now that we are going to deal with only BC integral. This one's only BC integral, which is sine square of x dx. Oh, you're like, oh my god, that's second degree. So that, what if I change to 1 minus cosine square of x? The problem of that is you didn't change anything because you don't have du. If you have u equal to cosine of x, you don't have negative sine of x. So then you say, okay, well, let's change this to 1 minus cosine of 2x. You change to the first degree, then it becomes a simple problem because you can also split. And with this is just a u substitution. So this one's going to be 1/2 x minus 1/4 of sine of 2x. Does that make sense? 1/4 sine of 2x plus c, I suppose. So you say, yeah, if a question is this easy, you can test me all day long, right? But it's not going to be like this easy. It's slightly harder. So now I have cosine to the 4th. If you integrate a cosine of 2x, it's equal to sine of 2x, right? Is that okay? All right, so how about cosine to the 4th x? So this one just, it's not much work. There's only small plot twists and a little bit more algebra. Okay? So what I mean by that is this. I can change that to cosine square of x and cosine square of x. This is kind of like same patterns before. And I can say, okay, cosine is equal to, well, cosine square, instead of changing to 1 minus sine square, because u equal to sine of x, du does not equal to cosine square of x, so that doesn't help me. So let's just change both of them. 1 plus cosine of 2x over 2 times 1 plus cosine of 2x over 2. This is the only time you have to use power reducing, when it's owning sine to the even power or owning cosine to the even power.
Why would you do both?
Yeah, because I'll show you in a second. If I just do 1, then that's actually make problem worse. Because 1 is 2x, 1 is x.
Yeah.
So that's worse than before. So I just unify everything and maybe just try out with u substitution. Now, for this, I definitely can split that. So it'll be 1/2 plus cosine of 2x over 2 times 1/2 cosine of 2x over 2 plus, and then I'll just expand them. So that was one of the strategy I mentioned when we start 8.1, which says a lot of time you can expand the function. So I'm going to expand this function. So 1/4 plus 1/4, so it's 1/2 cosine of 2x. So far, like, this is all integratable because this is just a simple power rule and a little bit of u substitution. But here, then you say, wait, how about this one? cosine square of 2x? Well, the whole thing is just reduced to the first degree. If you can reduce the second degree to the first degree now, you should be able to solve the problem. But there's a problem, right? The power reducing formula looks like something like this. Copy and paste like this, right? And and then what about cosine of square of 2x? So what do I do? No. Just replace all the x with what? 2x. So only the x. You replace that x to become 2x. And then that becomes a something that you can work with. So that's going to be 1/4 plus 1/2 cosine 2x. And this is a 1/4, right? Times by 1 plus cosine of 4x over 2 square. Don't ask me. You did it. I didn't do it.
You persuaded us, Mr.
I did not persuade anybody. Jenny, you volunteered to be here.
I still remember the conversation. You're like, Jenny, you're such a job. We need it in like this depressing class.
I did not say that.
Bernicia, you were there. Did he not say that?
After the month of like April, I tuned out the entire class.
Oh my gosh, this is
Because it's this is square.
Yeah.
Oh no, you don't have to square. You don't have to square. You're right. You don't have to square. You don't have to square. No squares. You're right. All right. So that's gonna be 1/4 plus 1/2 cosine 2x, and that's a plus. What's 1/4 times 1/2? 1/8, I think.
Plus 1/4.
And a plus what?
Wait here.
1/4 cosine 4x.
Well, it's gonna multiply by both. So it'll be cosine of 4x over what?
8.
Not 8.
It is over 8.
Oh, 8. Okay. I like. Dx. No, I cannot do simple math. I was thinking about 4 times 2 is equal to 16. Okay, so now just this two can add together because what's 1/4 plus 1/8? 3/8x, right? What's the integration of cosine 2x? It will be sine of 2x times half. So it'll be 1/4 sine of 2x.
1 over 32.
Okay. Plus 1 over 32
Minus.
sine of 4x
Minus.
plus c. Why is minus? Because derivative of sine of 4x is equal to cosine of 4x. So it's a positive. You're integrating. So if you take a derivative of sine of 4x is equal to positive, that's okay. I do that to that.
Oh, I did it. This took about 5 years.
Like I told my son, stop whining. Move on. Like I take my son to like condition for ping pong, so he had to like do a froggy jump throughout everywhere.
Do froggy jump?
Yeah.
How do you do froggy jump?
Brandon, you did like you put your hand on it.
Oh hell no! Oh hell no!
You like jump around his
And
Kingdom will demonstrate. No, you're
Was he even playing?
yeah, he's like, I can't do it so hard. I was like, shut the fuck up.
no.
What?
Oh yeah, get the demonstration.
Oh, it's the conditioning that happens.
Wait,
Perfect fit.
All right, that's it. We're in that class.
Right?